Okay. I need to. Why is it in progress? It should not be in progress. Start new class session. Okay. All right, y'all can hear me? Okay, so I just opened the cloud and somebody told me that my class automatically opened while we were out on hurricane. So I'm gonna go ahead and delete that. So just give me a day to get that fixed, but I will fix it. Okay, and then I just opened it and it said it was already in progress. I don't know what's going on, but I will fix it when we leave here. So let's do our attendance real quick. Okay, and I'm gonna switch over so it's on the screen. So everybody check in if you can. See the chat. Okay, while we are getting that started, what I want to do is I want to show you a few things about your exam. All right, our exam is next time we meet on Thursday, but it is online, it is on Moodle. So you may go anywhere you like to take it, as long as your area is clear, except for one sheet of scratch paper, which I'll talk about in a minute. But you could also come here. This room is available and I will be here. And I will have a stack of printer paper and I'll be here. If something happens, I'm here. So if you have a computer and can do that, that's great. There are some computers right over there. There's a room that has some Macs in there. And then if you go to Moodle, I go to Moodle real quick. Maybe that little X disappears right when you need it. Come on. Okay. So if you go to Moodle, let me hide that. And you want to know where else you can go, I have a little thing here all about our exam. So locations on campus that have computers with Respondus. There are multiple places that have computers with Respondus and a webcam that you can use. So there are options. But if you want to take it in here, you can take it with me in here, just on your computer. Okay? All right, so how's it going to work? That thing just keeps you high. Okay, there we go. All right, so what are you going to get on your exam? A couple of people have asked me that, and I am providing to you exactly what you're going to have on your exam. So you see this very first link here, exam resources, periodic table, conversions, equations. It opens up a PDF, and this is the exact PDF that you will have access to while you are taking the exam. So it has the periodic table. It has SI units and conversion factors. It has equations. Do you know where I got this from? The textbook. I took pictures of the textbook. That's all I did, right? And then if you don't know what an element abbreviation is, the name's right here, and they're alphabetical. Okay, so everything that you normally have inside of your textbook to help you while you're doing your homework or whatever it is, it's in the same place. I thought that would be the easiest thing for y'all. So you would know where to go to look for information. Okay, I'm going to show you how this will be incorporated into your exam in a second. All right, there's a video here that kind of tells you how Respondus exams work. So you should watch that. There are instructions here for downloading Respondus onto your computers. And then this is a practice Respondus exam. You need to do this practice exam. It's 3 questions. It's not really an exam. It's 3 ridiculous questions, okay? And it's just so that you can get to use Respondus and use the PDF that I gave you. So how do you make that happen? And I don't know if I connect my computer, the people at home won't be able to see this. So, I don't know, I really want to show y'all, but I'm afraid it's not going to work because I have Respondus downloaded on my laptop, but I don't have it, like I can't download it on this. So I'm gonna switch over and I'm gonna show you real quick kind of what it looks like. So if I switch over, if I can make this big. On the screen, yes. Okay. So I'm logged in here as a student, right? And here's my Respondus practice exam. I'm not in Respondus browser right now. I'm just in Chrome, whatever, right? So when you click on the exam and you've already downloaded the browser, you're going to see this blue button. And this is the blue button that you click to launch the lockdown browser and to take your exam. So it brings you to a new browser, right? And it's going to take you through a couple of steps that you have to do. So you're going to want to start, it's not a quiz, it's an exam, but you're going to start quiz. And then it asks you to do a couple of things to make sure that, that you're doing the right thing. So this is your terms of use. It's going to check your webcam. Does your webcam work? Woohoo, where webcam works, yes. Right? Make sure that your image fits inside of the window. I don't want to see like just the top of your head, like this, right? Don't do that because I will go back and look at the videos. And it's going to tell you to record a 5-second video just to make sure that it's working. And it's recording. It's just like a check to make sure everything's working. So this little like stepwise thing takes you a few minutes to do. Continue, right? Additional instructions. During this exam, you shouldn't access any other resources, a phone, tablet, notes, book, or communicate with other people. Please stay in your seat, focus on the computer screen until the exam is complete. If an interruption occurs, explain what happened by speaking directly into your webcam. I can go back and view it. And finally, remember that you cannot exit the exam until all questions are completed and the test has been submitted for grading. Once the exam begins, you'll be able to use a link to access the periodic table, equation sheet, and conversion table. Okay, so make sure you're someplace where you don't hear anything. Come on. This room in technology. Why don't I get that? This is not good. Come on. Maybe it doesn't like me projecting with Respondus. All right, well, I'll tell you what's going to happen next. Because now my screen is black. I bet Respondus didn't like that I was projecting. Respondus is pretty picky, which is a good thing. But it'll ask you to show your face. It'll take a picture of your face. And it'll ask you to show an ID. So you'll take your ID and you'll put it in front of the screen. It could be your Nichols ID, it could be a driver's license, doesn't matter. And you show the camera your ID. It'll take you through all those steps and it'll say, are you ready to take the exam? You click start the quiz. I'm telling you that you can have one sheet of scratch paper. So before you start answering your exam, you're going to show me my scratch paper is blank. Right? You show the screen front and back. My scratch paper is blank. Could be loose leaf, could be printer paper, I don't care. If you're going to take it in here, I'm bringing a pack of printer paper, so you don't need to bring it. I'll have some. So just show me it's blank, and then you take your exam. So when you start taking your exam, what it's going to do is it's going to look sort of like this. You'll have more than 3 questions, I promise. But this is just a practice, right? For your exam, every single person's first question will be those resources that I gave you. It'll be the picture and it'll be this exact link. And when you click on this link, even when you're in Respondus, it will open a new tab just like it did there. And you'll be able to go back and forth between your exam and your resources. Okay, and if you ever, oops, I closed that, and I'm already on question number 3, and I accidentally closed my tab that had my resources, what do? Go to question 1, click on the link, and it opens it up again. So you're never without it. Okay? Make sense? All right. Any questions about, because I talked about doing the trial, you need your ID, you get exam resources, we talked about scratch paper. The last thing, let me exit out of this. Oh, I think I have to like finish it. Next page. There's the 10. Oh, there it is. Okay. All right. Exit out of this. Finish review. Okay. So once you're done, you've taken your exam through Respondus, right? You've done that right here. You have that sheet of scratch paper. What you're gonna do is you're gonna use your webcam to take a picture of it, front and back, and upload it right here. And this will link your scratch work to your exam, okay? You have to take a picture of your scratch work. What if your scratch work is blank when you're done? Cool, you did it all in your head. You still have to take a picture front and back, okay? Read those instructions. Make sure you follow all the instructions. And if you want help, come here, I'll help you. We'll just spread out a little bit more than we are normally in a class, okay? All right, questions? Which I think I haven't even looked at the chat. Where is my chat? Is my Zoom off? What happened to my Zoom? It's here. There it is. Okay. Here we go. All right, so nobody asked anything on the chat. No, cancel. Okay. Questions? Good. All right, you ready to finish the material? Dr. Smith is a little ahead of us, but that's okay, because he had his exam today. All right, so let's do a quick refresher. I got a couple of clicker questions for you. We did that. All right, here we go. Let me end our attendance. All right, so we're going to start a new multiple choice question. How many neutrons are in an atom of oxygen 18? Yes, ma'am. It won't log your points.
I know, but it's like...
Log out completely and come back in. Like close it completely. It says you need a subscription. So if you started on a trial. So if you started on a 14-day trial, you're going to have to buy the subscription. There, on the syllabus, there's a link, and that link will take you to a $5 subscription. Once you follow that link, they will send you an email. In the email, there'll be a code. You go to, in your browser, not in the app, in a browser, you go to iClicker.com, right? And log in, and there'll be a place to put the code. But you have to do it in a browser. You can't do it in the app. Okay, so try to get that done as quick as you can so you can join in. So I'll give y'all another 30 seconds. How many neutrons are in an atom of oxygen 18? Got 2 minutes, I'm gonna turn it off. So you got 5 seconds. Okay, so what did we say? Let me move this over. So majority said good, 10. How did you know that? What's the 18? Mass number. Our mass number is number of protons plus number of neutrons, right? So you have to take your mass number minus what? Number of protons, which is 8, and that will give you your number of neutrons. So 18 minus 8 will give you 10. All right? Okay, let's try another one. Oh, don't look at the screen. Here we go. How many protons are in an atom of nitrogen 15? How many protons are in an atom of nitrogen 15? If you're looking close, I spoiled it. Okay, I'll give you all till 1 minute. Okay, so what did y'all say? And it should be 7, so it should be B. How did you know that? Number of protons doesn't change. If you're nitrogen, you have 7 protons. Does not matter what your mass number is, doesn't matter what isotope you are, you have 7 protons, period. If you have 8, you're a different element. If you have 6, you're a different element. Good. Okay. Oh, and I gave away that one because I messed that one up, but so we're just skipping it. Okay. What daughter nucleus results from radon-222 undergoing alpha decay? So this one, you might have to get out a sheet of paper and write. I'll give y'all about 2 minutes. I know it takes you a minute. So try it out. We have radon-222 undergoing alpha decay. I'll give y'all another 30 seconds. So a minute 30, because I see kind of low on responses. So I'll give y'all another 30 seconds. Okay, almost time. All right. So what did we say? Okay, E, good. So how did you do this? 222, what is radon? 86 protons, and what's our symbol? Rn. And we're going to decay, and we're going to undergo alpha decay. There are two different ways that you could write alpha decay. You could write the little A symbol, or you could write He. But what's your mass number always going to be? 4. What is your atomic number? 2, because it's really a helium nucleus. So a helium nucleus has 2 protons, 2 neutrons for a mass number of 4. Okay, so either one of this one or this one in that place is fine. Okay, so what are you going to make? 222 minus 4 is what? 218. What are you doing? I had this problem last class period. When I write, it advances the slide. And I don't know why. Try a different color. It's not working. But y'all are right, 218. It's like this slide doesn't want to work, and I'm not really sure why. Do you see it clicks? Okay, so it would be 218 at the top, and then what would be at the bottom? We want both sides to be equal. So if one side's 86, the other side has to total 86. So 2 plus what is 86? 84. So if it were 84, what element has 84 protons? Polonium. So would it be D or E? It would be E, because that number after it should be your mass number, not your atomic number. Right? Okay, let's see if I can make the rest of these work. Stop it. Okay, try this one. What daughter nucleus results when carbon-14 undergoes beta decay? I'll give y'all until 2 minutes. Okay, so what do we get from beta decay? You should get nitrogen 14, but let's try to explain why. Let me see. Let me see if I can put it on here. This. And let's do it again. we're going to get around this. For some reason, it works better with certain programs. Okay. So we have nitrogen 14, right? What was nitrogen 14? What was it? Carbon 14. Hello. Carbon. Okay, so you have carbon 14. What happens in beta decay to carbon 14? And what's the atomic number for carbon? 6? What happened? Okay, so what do we write for beta decay? A -1 and a 0 on top, and what's our symbol? E, or you could write beta, E -1. Either one's fine. Okay, so what do you make? Well, so our mass number is not going to change, right? 14 plus 0 is 14. That's good. What should my atomic number be? 7, because 7 minus 1 is 6. So if you go and look on the periodic table, the element with 7 protons is nitrogen. Okay, look at that, work around. Maybe, if I can get the internet to come back. Oh, I just put it down low. Okay. We'll get it. All right, here we go. One more, last one. Okay, the half-life of gallium-67 is 78 hours. How many half-lives must pass for 80 milligrams of gallium-67 to decay to 20 milligrams? So this is based on the videos that you watched in preparation for today, right? Okay. So I'll give y'all until about a minute and a half. 2.5 minutes, not a minute and a half. 2.5 minutes. Not as complicated as you think it is. If you have it run in, yes. Please don't leave it blank. Please guess. Please guess. Okay. All right, so what do we say? So it should be D. It should be D, but I can see we had a lot of guesses there. So let's talk about this, right? We have gallium-67 has a half-life of 78 hours. Did we need that for this question? That was extra information that we didn't need, right? So how many half-lives must pass for 80 milligrams to decay down to 20? So what happens with one half-life? It goes to 40. We go again. What do we got? 20. So how many half-lives? Y'all tried to do a lot of math with that, didn't you? No? Good. Don't let me trick you. Don't let me trick you. Oh, I did have a few more. I thought that was it. Okay. Let's try another one. What type of radiation can be stopped by the skin? That's straight from lectured reading. Give y'all until 1 minute. Okay. So what do we have? So it should be, you should have picked A. A is the kind of radiation alpha particles that are stopped by skin. What happens if you inhale something that is undergoing alpha radiation? It's dangerous. You don't have skin in between you and your internal organs if it's ingested or if it's inhaled. So it's super dangerous. And so if you walk through an area that's been contaminated by some kind of radiation and it's alpha radiation and you inhale it, you can have serious internal injuries. Okay. Acute exposure to 1 to 2 Sieverts of radiation has an LD10. What does this mean? What does LD10 mean? Okay, 5 seconds. Oh, only 22 responses? I'll give you all till 1:30. All right, if you haven't run in. Okay, so what does this tell us? Oh, so you should have said that it was D. So what does LD stand for? Lethal dose. So if it's lethal dose, you need to have an answer that has dye in it, right? It's lethal. That means it's going to kill someone, right? So what does the 10 refer to? 10 is the percent. So 10% of people exposed will die, but they're not necessarily going to die right away. When you have radiation damage to the body, it usually damages the DNA, and then you have problems in subsequent replications. And so usually you don't die immediately, but gradually over couple of weeks. It's pretty terrible. But so LD10 would be 10% of people exposed will die within 30 days. What if it was an LD50? Is that more or less dangerous? That's more dangerous because it would be 50% of people exposed will die within 30 days, right? What about LD100? Means everybody, right? Not good, not good. Okay, I think that is the last one. Okay, it really is the last one, I promise. All right, so now we need to go and do a couple of problems. So here are in-class problems. Oh, and I clicked the wrong thing. Okay, let's try that. We're going to put our width, and we're going to go down to section 6, right? Y'all ready? Okay, so I did the first 3. Define half-life. Now that we've kind of done a problem with half-life, what is the definition of half-life? Who wants to help me out? When we say life, what do we measure our life in? In some kind of time, right? You're 20 years old, you're 50 years old, you're right, that's time. So half-life is the time it takes what? What does the half refer to? The time it takes half of the radioactive material to do what? To decay. Why do we say decay? Why don't we just say vanish? It doesn't go away, it changes. And so that change is a decay because we usually change elements. Not always. All right. Xenon 133 is used for imaging the lung. The recommended dose is 15 millicuries. If Xenon 133 arrives in the laboratory in a package containing 120 millicuries, how many patients can be treated with the contents of this package? This is going to be a dimensional analysis, right? We're converting units. So let's pull out the information that we have. What kind of information do we have in here? We have a recommended dose, which is millicuries. How would I write that as a conversion factor? 15 millicuries per dose. Sure. If Xenon 133 arrives, right, and our package contains 120 millicuries, how many patients? All right, so what we're starting out with is 120 millicuries. And I want to convert that to patients, but do I have a conversion factor that's going to get me to patients? No, but we know, because the problem didn't say otherwise, that there's 1 dose per patient. So you could change that dose to patient, or you could say, right, if we were doing 15 millicuries, because we want to cancel out our millicuries per 1 dose, and we know in 1 dose, we could treat 1 patient, right? So we end up just with 120 divided by 15. What do you get? 8. 8 what? Patients. What if I were told in this problem that it takes 5 doses to treat a patient? Would that have changed my answer? Yeah, it would have been 5 doses per patient, but they didn't tell us that. Good? Got to be able to do that dimensional analysis. If not, it's never going to leave us. It will be with us forever and ever. Okay. Titanium-99m is very useful in diagnostic imaging since it has a short effective half-life of 4.8 hours. If a patient receives a dose with an activity of 50 millicuries of titanium-99 for cardiac imaging, how much radioactivity will be left in the patient's body 48 hours after injection? Okay, what are we going to do? We're being asked for how much radioactivity will be left. Don't you have a formula for that? We could do this the long way or the short way. Do you have a formula you want to use? Yeah, so what's left is equal to 0.5 or 1/2, however you want to say that, raised to the n times your original, RGI, original, is that right? Amount. So how much do we have left? Can we plug this in? Why not? Well, we're trying to solve for what's left. So I could write 0.5. What should I raise it to? Here's my problem. I don't know how many half-lives that is, right? I just know it's 48 hours after injection. Can I convert that? 48 hours. Can I convert from hours to half-lives? Because I know that in 4.8 hours, I have how many half-lives? 1. Right? Because it says effective half-life of 4.8 hours. That means 1 half-life is equal to 4.8 hours. So I can make that a conversion factor. So how many half-lives are we talking here? 10. So now do I know what to raise my 0.5 to? Absolutely. So 0.5 raised to the 10 times my original amount, which was 50 millicuries. Everybody know how to do exponents on their calculator? Yeah? So you need to make sure you know how to do that. Or you could use the respondus calculator. So you might want to practice that as well when you practice the respondus, that you see how their calculator works, just because it's good to have a backup. Better safe than sorry. Okay, anybody got, well, we have to memorize that formula. I gave you all the formulas that are in the back of the book. That is not one that's in the back of the book. So if you want to do it the short way with the formula, you would have to memorize that one. And the test is all multiple choice. Yes. So what do y'all get? Number 40. What do y'all get? 0.049. Yeah? Okay. That's kind of the short way. Do y'all want to know the long way to do it, just in case you forget that formula? It's good to know. It's good to know, right? So if you want to know, you could just do the half-life until you get to 48 hours. So you start with 50, right? What's 1 half-life? 4.8 hours, right? That's 1. Half of 50 is 25. Do another half-life. 4.8 plus 4.8 is, what's a 2, carrier 1, 9, 9.2, right? So half of 25 is 12.5. We're not there yet because we haven't gotten to 48 hours. We need to get to 48. So what's another 4.8 hours? Somebody with a calculator, help me out. 8, 9, 10, 4, 15, 100. It's 14? How do I do that? 14? Now save me. Okay, so 12.5 divided by 2 is 6.25. right? So that's 4. So we need to add another 4.8. 18.8. Okay, so 6.25 divided by 2. 3.12. So we got to keep going, right? Until we get this number on the top to be 48. So could you do it if you forget the calculator? If you forget the formula? Absolutely. It might take you a little bit longer, but you could do it. So I think I'm going to run out of room, but you get the point. You're trying to get this number right here to 48. And then you would just count the number of half-lives. Okay. Now we're going to go on. All right. Ooh. So now we're going to start using radioactivity in our patients. So what's a diagnostic tracer? How's that different than treating somebody with radioactivity? Right. So it's a, but what is it? Diagnostic tracer. You're right. We want to diagnose our patient, but what are we using to diagnose our patient? It's still what? It's still radiation. It's still radioactive, and we don't want to use a lot. So it's really a small amount of radioactive material that is used, like y'all were saying, to diagnose a patient. Right? We're not trying to kill their cancer. We're just trying to find out where they have cancer. That's it's a different way to do things. So what are the preferable characteristics? I gave you a hint. I gave you one. A long half-life? A short half-life. We want a short half-life, right? Because we want the body to clear it as quickly as possible. And what about this? You're going to give the patient a lot? A small amount. And when you were reading your book, did you read about those little pellets that they actually embed in tumors? Right? Super dangerous, but it works. So what's the point? Why is it better to embed this little bit of radioactive material instead of just putting it in an IV and putting it in their arm? It's localized. We're providing radiation to a small portion of the body instead of pumping it through the entire bloodstream. So a lot of times what they'll try to do with a tracer is a short half-life, a small amount, and if possible, a limited area of the body. Sometimes we don't know where the problem is, and so we have to put it in the bloodstream to kind of identify where the problem is, but sometimes you already know that. You kind of already know where they're having medical issues, and so you're looking in a particular part of the body to start with. Okay. All right, last one. Radioactive iodine 123 has an effective half-life of 12 hours. If a dose with an activity of 1.5 millicuries of iodine 123 is given to a patient for a thyroid test, how much of the iodine 123 will still be active 36 hours later? You try it. I'm going to show you both ways when we're done, but you try it. Okay, looks like y'all are winding down. So let's do the short way first. Let's do the formula way first, right? So we know it's what's left is equal to our 0.5 raised to some power times whatever we started with, right? So what do we know? 0.5. Do we know N? How did you figure that out? So you have 36 hours, right? And we want to go to half-lives. So we know in one half-life, we have 12 hours. So that converts our hours into half-lives. So we have 3 half-lives. So we can put our 3, and what do we start with? 1.50 millicuries. Put your units, Dr. B. And what do you get? 0.19 millicuries. What happens? Oh my goodness, I'm on the exam. I forgot the formula. Do you freak out? No freaking out. What do? You say, okay, I'm starting out with 1.50 millicuries, and I want to know 36 hours later what happens. So I'm going to go 1 half-life. That's 12 hours. 1.5 and half is 0.75, right? We're going to go another one. 12 and 12 is 24 hours. What do we have left? 3.375. Fucking right. Another 12 hours. Well, actually, let's do this. This is really 24 hours have passed. Let's do that. So then another 12 hours is 36. And that's 3 half-lives, and we end up with the same 0.19. And the reason I did 0.19 instead of 0.187 is why? I have 2 significant figures, 2 significant figures, and 3 significant figures. So I stick with my 2. Yeah? All right, that is the end of the material for the exam. What do you need to do? Because not everybody has used the test respondus exam, the 3-question mock, pretend, practice exam, whatever you want to call it. You need to do it. Please, please. I'm ending early today so that if anybody has technology issues, all that kind of stuff, I will help you. I will be here in this room on Thursday for your exam time. Come take it here with me. Perfectly fine with that, okay? If you have questions, send me an email and say if you need help. I'm happy to help. Any questions? All right, good to go. Good luck studying, and don't forget homework is due tomorrow night, 9 p.m.
And I had this problem with my already wanted to because I had to use it. So just to show you, it is downloaded.
Yeah.
I will also
Oh, let me end. Anybody at home have a question before I end this? Okay, if you have one, send me an email.